to know about SI prefix, okay? Milli, kilo, mega, giga, tera. It depends on symbol and prefix. You can make a conversions and the power exponential you have to know, okay? And also micro, nano, and the pico. It's very important, okay? And you have to know about the unit conversions here. The unit conversion is 10 to minus 3 is equal to 0 0.001, okay? Or sometimes 10 to 3 is 1,000, okay? And also we're gonna learn about the engineering notation. And scientific denotation, okay? You have to know about what it is, how can we make a definitions, how can we make a conversions between two of notation, okay? So some student has a lot of mistake. 1/1 milli, 1/1 milli means 1/10 to minus 3, because that is the milli. 10 to minus 3 is 1/10 to 3. So 1/10 to 3, it was 10 to 3. That is the math, okay? Please be try and practice to make a familiar with this formula. And for example, the 1/10k, the k is the 10 to 3, and 1/10 the multiply 10 to minus the 3. The 10 to minus 3 is milli, and that is also 1/10 is 0.1, okay? All right, so by understanding about, to understand the Ohm's law, we have to try now 3 basic concepts: voltage, current, and resistor. So voltage is the potential difference between the 2 points, okay? And V, voltage, is equal to energy divided the charge. As the unit, the V is equal to joule divided the coulomb, okay? I'm going to really quickly go over because that is just only the review, okay? And 1 coulombs here, 1 coulombs is the equal to 6.242 the 10 times the 18 the electrons, okay? All right. So 1 voltage, the definition is the total of 1 joule of energy is used to move negative charge of the 1 coulomb, let's see, okay? So really simple, the example, 60 joule of energy required to move a charge, the 20 the coulombs between 2 points. What is the voltage? It's very easy, okay? Energy divided charge. That was 60 joule divided the 20 coulombs. That was 3 volt, okay? Don't missing the unit. All right, the current, usually the current is I for DC current, small I, the AC current, okay? So the current is usually could be defined as flow of electric charge, okay? So the current is I symbol, the unit A, okay? So the current is like the 1 ampere. And also, we're gonna, the I I'm gonna check it for you. I is Q over T here, okay? All right. So from example, we can do this 64 millisecond over 0.16 column. Keep in mind, 64 times 10 to minus 3, 0.1216 column. So after we're gonna use in calculator, divided 64. 2.5 M. Okay, so that was for the answer. So usually supply voltage could be battery generator and power supplies. And for the DC, that was the symbol, okay? The positive, long bar, negative, short bar, okay? There's a schematic symbol of the battery. And that is really simple, the DC circuit, which consists of the battery, the voltage supply, and register, okay? For this case, conventional current is from the plus to the minus. However, the electrons flow over from minus to the plus, okay? That is what you have to know. All right, so now we have also learned about before the ampere to hour rating. The ampere to hour rating. Ampere to hour rating provide indication how long a battery of a fixed voltage will be able to supply a particular current. So 100 ampere hour rating could be provided 1 ampere for 100 hours, the 10 amps for 10 hours, 100 amp for the 1 hours, okay? And also that was the equation about the life of the battery is equal to ampere hour rating divided the ampere, okay? So for example, how long the 9 voltage battery with an ampere rating is 520 milliAh provide current 20 milliamp. So so that wanted to looking for how long mean is like the life, okay? They're looking for ampere rating divided the ampere. So 520 milliAh divided 20 milliamp. That was 26. Okay. The 26 hour. So that was the answer. Okay. Okay. There are 3 types of the materials. Okay, but the first over we wanted to learn about the insulator, conductor, semiconductor. Semiconductor, most commonly used semiconductor in electronic devices is silicon, the germanium, and gallium arsenide, okay? And also semiconductor generally have 4 electrons in the outermost valence ring, okay? So semiconductor is also specific group elements exhibit characteristic between those insulator and conductor. So silicon is also the outermost valence, like four electrons. Germanium is like 32 as well. The outermost cells like 4 electrons as well. Okay. So when you measure current or voltage, you need to follow the connections approach. So the ammeter are used to measure the current, the inner circuit. For this case, you have to the broken circuit and plus minus to current flow through emitter and then be measured. However, the voltmeter should be leading the red one plus positive, the high, minus the black one from DMM is negative, okay? So that was you needed to approach to measure voltage current by using the DMM, same thing, okay? Connect a multimeter in parallel to measure voltage drop across the light bulb, just the LED. I mean, this is the rod here, okay? And also, if you wanted to measure current, then it should be broken circuit, plus, plus, and minus, minus, okay? All right. Register, okay? Register. The unit is register could be the formula as R is equal to rho multiply L over A. A is cross-sectional area, especially circular mills. L is the length of the sample. And to calculate R, again, we needed to understand the four main factors to effect of register. One is the cross-section area of conductor, length, material characteristic, and temperature. But usually temperature is like room temperature 20 the degree. So this is why we're gonna could be the calculate by these the equations. Okay. Okay, the circular mills, very important, cm. The mill is a unit of measurement for the length. Again, the mill is the unit of measurement for the length. It could be related to the inch. So inch to the mill to the inch. So you can make both of them between the two of them here. So 1 mil is equal to 1/1000 inch. And 1 inch is equal to 1000 mils. So a wire with a diameter of the 1 mil has an area of 1 circular mil here. Okay? 1 circular mil. So if you wanted to calculate the area of a circular wire in a circular mills, could be defined as A sub cm is this mils, the diameter, in terms of mils. So any diameter, you have to change from the inch to the mils, and that diameter, you have the square, that is the area of the A sub cm for A in the register, okay? So, for example, the 2 mils of the diameter is like the 4 circular mil. 4 circular mil is like this one, 1, 2, 3, 4. And 3 mils, that also square, 9 mil, like this one here, okay? And that was resistivity rho of various materials. So if we wanted to know if they given A, R, L, or we can find A, R, L, we can find the low. So A unit circular mil, R unit ohm here, L is usually feet, okay? If you know the 3 components, we can find the rho resistivity, okay? All right, so one of the sample here, resistance, what is the resistance? 100 feet Cooper wire with a 0.02 inch diameter. So here from the given, L is 100 feet. And characteristic of resistivity from the table, that is the Cooper. The Cooper is 10.37, and the diameter is for 0.02 the inch. So now 0.02 inch, that should be change mils. How? Because go back to the slides, 1 inch, 1000 mils. Okay, 1 inch is 1000 mils, and 0.0 inch, what mils? So that was mils, diameter mils is 20 mils, okay? So the 20 mils we learned before, the square, finally 400 circular mils. So now here, that is formula to find R, because the question is looking for R, register, rho, the given Cooper, and length is 100 feet was given, and we find 400 circular mils. So finally, R is 2.59 ohm here. To find, oops, 2.59 ohm here. Okay. All right. The another questions is find the length of a Cooper wire. If it has a diameter 1/16 in R is equal to 0.5 ohm. So the length R low, length A. So length is low R A. So R is what? 0.5. The A we have to find, and rho is Cooper, is same thing, 10.37. So we have to find the A. If we find A, we can find finally L, the length, okay? So how can we find L? So 1.16 inch, we have to change mils, okay? So how can we find? Same thing. So back to here, 1 inch, 1000 mil. 1 inch, 1000 mil. So skip the calculations. The mils, the diameter mils is 62.5 mils, okay? And that was for the A sub CM. 62.5 mils square, okay? Finally, 3006.25 circular mils, like this one. So here, right there. So finally, L is 188.34 feet, okay? Okay, the register code. The register code. For example, red, brown, orange, gold. From the table, you can find the corresponding red is what? 2, and brown, 1, and orange, 3, and gold, plus minus tolerance, okay? So that was 21 is the third band is the exponential power and plus minus 5%. Okay, that is the answer. And from the number, we can find the fourth band, fourth color band, 2 red, 2 red, 4 yellow, 100, right there, red here. And finally, the 10% is what? Here. Something like this, okay? All right, one more time, very important. The Ohm's law. The Ohm's law is E is equal to IR. The R is equal to E over I is equal to E over R, okay? This is a really basic circuit. This is battery plus high potential, low potential, the current from plus to the minus. So after passing the current of the resistor, they arise at the voltage drop, V sub R. So usually E is equal to V sub R because we don't care about the losses, okay? We learned before the resistor here, the plus to the minus, the high potential to the low potential, the current flow, okay? This is very important. So the circuit, 9 voltage and 2.20 ohm, that was 4.09 amp, okay? And 120 volt divided R is I, but I was given and E was given. We are looking for R. How? Okay, E is the Ohm's law, I times R. R is E over I, right? E is 100, 120. I is 500 milliamp. That was 120 volts divided 500 times 10 to minus 3. Finally, 240 ohm. So to keep in mind, 500 milliamp over 1 is 500 times 10 to minus 3. 10 to minus 3 is 10 to 3 divided 500. So I strongly recommend you can use the calculator, okay? That should escape the, mistake. Friday. All right. So the DC power formula, P is equal to IE. And after we're gonna using the Ohm's law, we can also rewriting I square R, also E square R, E square over R. And 1 horsepower is 706 watts. And usually power, the unit is watts, okay? Watts. Also, it was 1 joule per second, okay? My E times I, or sometimes V times I, and I square R, or E square R, or V square R, okay? Very important. So it depends on the given value. We can find the formula for the P finally we can find the watts. Okay. Maybe again, the efficiency is output power divided the input power. But if we wanted to add it to the percentage, the unit, that should be P sub I multiply 100. So what is the output in the horsepower of a motor with an energy efficiency of the 80% and an input current of 8 amp at the 120 volt? So the input current and voltage, we can find the input power by using the formula Vi, and the efficiency, the 80%, 80% means that was 0.8 multiply the input power, which we have already calculated before. Finally, P sub out 768. But the question is looking for horsepower. What is horsepower? 1 horsepower, 746 watt. Now we have a 768 watt. What is the horsepower? Right, this one. So finally, the output horsepower is 1.03 horsepower. Okay, same thing. You have to check. All right. So the total register in the DC circuit, we can adding up right there. Okay. And KVL rule, very important, Kirchhoff's voltage law. The algebraic sum of the potential rise and drops around the closed loop is the 0. Okay. So the voltage from minus to the plus, up and downward and downward, plus to the minus, minus to the plus. V sub R sub 1 plus V sub R sub 2. Okay, so that was my 10 volt, 5 volt. That should be the 5 volt. Okay, plus 5 volt. There's a 10 volt. That is the KVL rule. Okay. So if you wanted to, for each voltage drop, the register, the first of all, you have to find the I sub t. The I sub t is total current. The total current is E over R sub t. E over R sub t is R sub 1 plus R sub 2 plus R sub 3. Okay. So that was 10 volt, 1K, 500, 2K. That was 3,500, the 10 volt. Okay. That was for I. And finally, that was 2.85 million. Okay. Right there. So maybe if you find the I sub t, you can find the I sub R sub 1 times R sub 1, I sub R sub 2 times R sub 2, I sub R sub 3 times R sub 3 for each respectively voltage. But in the DC circuit, the current should be the same. Okay, I sub R sub 3 and I sub t. We have already, the confirm from the lab session. Okay, so that was the one of the sample exam. The given is I sub t, R sub 4, R sub 1, R sub 2, and V sub R sub 3. What is for R sub 3? Okay, because V sub R sub 3 and I sub t multiply R sub 3, but we are looking for R sub 3, right? So here, R sub 3 is V sub R sub 3 divided I sub t. Why? Because I sub R sub 3 divided R sub 3. Same thing, right? Here, so I sub t 5 million over 10 volt. That was 2 k ohm. But keep in mind, 1 over milli is the kilo. Okay. Don't forget it to the mistake. What is the R sub t? The R sub t is same thing. R sub 1, R sub 2, R sub 3, R sub 4. R sub 4 we have already calculated before from the A. And what is the maybe E? E is the total current multiply the total resistor. Total current was given. And the total resistor we have calculated before the R sub t. And that was 35, the voltage. And then voltage drop R sub 2. What is the V sub R sub 2? Same thing. I sub R sub 2 multiply the R sub 2. But I sub R sub 2 is equal to I sub t. I sub t we have already calculated before. R sub 2 was given, right? R sub 2 was given 1 kilo. So now that was the 5 voltage. Milli multiply the kilo is 1, nothing, okay? And what is the total power being dissipated by the entire circuit? That was P sub t is equal to I sub t squared times R sub t. Keep in mind, they are looking for total power. So step 1, you have to find the formula, V times R. You have to find the total voltage divided the total current. Total voltage is E, the battery, times I sub t. All right, or you can I sub t square, R sub t square. So maybe it's up to you, okay? And the last question is, what is the power being dissipated, the R sub 4? So the one of the equations for the power is I squared times R sub 4. I sub t we have already calculated, and R sub 4 is the given. Why? Because in the circuit, as I said before, the I sub R sub 1 and I sub R sub 2, I sub R sub 3, I sub R sub 4, it should be the same. Okay, so it's equal to I sub t. Very important. So this is why 5 milliamp squared times the 2K, that was 50 milliwatts. Okay, keep in mind, the power is the unit watt. Okay. Any questions? All right.